me, it seems like it's a good exercise that you can do with kids, and they can actually see the parallels and the differences.
Yeah.
Here it is right there.
Yeah.
So that's cool. You get the same answers. It just takes less space,
Yeah.
Mm.
which is the way nature does it.
Right.
And what I love about this is here's this angular momentum kind of thing.
Mm-hmm.
We get the phi. We get the phi going on, right? Because if I put that in a circle. If I put this in a circle, do I get phi, Manu? Do I get phi if I put a circle around a square? Or do I only get, I guess phi has to be 1/3 of the circumference.
I'm just coming in, so
I know. We're just coming in. Okay, well, that's cool. Wow. And then we got a formula. One day we got a formula for determining how many triangles were going to be in that next level, right? This is the n squared minus 1, the n squared minus n formula. And it will predict the number of triangles in the next level.
Well, that formula doesn't predict the number of triangles. It predicts the number of connections between the triangles.
Yes, but it also predicts the number of triangles at the base of that thing. In other words, you can do it both ways. I remember from a discussion.
Oh, okay.
It will tell you the number of connections, but then but it also tells you if you have to step back and it'll tell you the number of triangles on the bottom level. 1, 2, 3, 4, 5, 6, 7. I don't remember where it is. I've got it in my notes someplace.
Mm.
Maybe I can find it. Maybe what we'll do is we'll go ahead and start the call, and then and I'll move it back up here to our curtain page. And I also wanted to, before we start the call, I wanted to share this about facts. So let's see if did I push the share sound button? Yes, I did. Here we go. So this is a little aside. Here we go.
I think we're at the beginning of the counter-enlightenment. The propositions, the Enlightenment view of man is wrong. And this, out of the Enlightenment view came science. But the science now indicates that the Enlightenment view of man is wrong.
What do you mean?
Well, the Enlightenment types believed that we could orient ourselves in the world, let's say empirically, and this is Sam Harris's proposition, you can abide by the facts. You can orient yourself as a consequence of the dispassionate analysis of the facts. You can't. And I would say the artificial intelligence engineers have figured that out. The postmodern literary critics have figured that out. The psychologists and physiologists of perception have figured it out. And the neuroscientists have figured that out. So it's not just the evidence that view is necessarily incorrect, is overwhelming and multidimensional. You can't orient yourself by the facts. Why? Because there are as many facts as there are things. In fact, if you combine things, the nature of the combination is also a fact. So there's as many facts as there are things and combinations of things. Well, you can't orient yourself by that. You drown in chaos. It's like you're standing in the desert and there's an infinite number of directions you could go. Well, how do you choose a direction?
Isn't that cool?
I think we're at the beginning of the...
I'm going to pause that. I'll put the link to that in the recording. Manu, we're about to begin the call, Manu, but if you want to make a comment on that, please feel free. You want to make a comment on that, or you want to start the call?
No, I want to make a comment.
Okay.
Not on that specifically, but on something that you say. And I want to bring something that makes it a little bit easier. And I will bear on this one too. Okay. I lack for lack of appropriate tool, I have this. Do you see my purse?
Yes.
In my purse are pencils.
I'd rather there was money in there, but I'll take the pencils.
No, there are some coins. If you want to have
good.
the value South African rands.
I'll be right over. I'll be right over.
They are, okay, they are coins. But let's just say I want to define this pens, this purse in terms of writing. I would say this purse is the number of pens that are here. I might give the color of pens, you know, red, blue, black, or whatever that are in there. That is the structure. To structure is to put it into segments that are linked to form a polyhedron. So in terms of a function of writing, this is my purse. That's what it is. That's what I described. But the reality is that this is not only my purse. It is this, but it is this envelope. Oh, sorry. It is this red envelope here. And it is the coins that didn't serve any direct purpose into my counting of pens and pencils. What is here that didn't serve any direct role into the counting of my pens and pencil is the phi. See. So hold on. It is the phi. It comes from my ability of discriminating the content of my purse into what I can count for a purpose that is vectorial, that's going somewhere, and what is left, but is left in this finite body. And this is the boundary of it. The three of these form a system. Triangle is a system, is a basic system. The envelope, what I can count, and what is remaining that I could not count, but it is relevant. It is in the back burner. That is the first comment that I make in regard to a comment that I heard Steve making. He asked me the question, if you put a circle around a triangle, will it have a phi? The second observation is that in my counting of the things, because I'm inside here, I actually don't see this. I imagine this boundary. Because I'm one of these things here, I'm counting, no matter how many pieces that I make, I can only make a countable polyhedron of things that I can count. That's what AI does. That's what computing does. That's what, what's the name again of a Canadian guy was talking about. So for as long as I haven't imagined my whole, that is, taking into account my being inside here, but at the same time also the whole thing, I'm going somewhere, but that somewhere is not complete. I wouldn't say I'm going nowhere. And that is a conundrum that has engendered all of the talks that we have today. There are people who ideologically refuse to consider the whole first, and then what they know in to make something that is dual, that was made for a purpose. So that was my comment. Okay, I'm through, Steve.
Cool. Okay, let's start our call.
Just staying on that
ahead.
for a second.
Right.
If it goes back to what you were saying about the formula, I think it applies that if you go to the pencils and the coins that are in that purse and you count them, so you'll know the components that are in the purse. They're different in the sense of makeup, but they're pens and they're coins. And so if you add them all up in your purse, and then you apply that formula, you would get some idea, well, you'd get an exact idea of the number of relationships between all those things in the purse.
Yes.
And so, and as Manu was saying, that you can count the things and you can see them, but you can't, and you can count the connections between them, but you can't see them. You can't see the connections. They're just there. And the only way you could count them is if you tied a string, if you want, between all of them, and then you could count the string connections, and you would see how many, and it gets complex very quickly.
They refused to understand Euler's identity. It was topological. And that is the problem today. Euler did it. When was it, Steve? In the 18th century or 16th?
I don't know.
Euler.
I have to look him up.
But it's at least 300 years ago. Out of his mind popped this formula that in a system, what is what you have? And it hasn't been disproved in 400 years. It just stands. And that is from him, Euler, considering the whole. And to do that, you cannot do it in a linear way. You have to jump. You have to let your mind free to imagine that the sum of these things that I can see or that I can feel, there is something missing. And then you imagine. And imagine in a way that it set a relationship. That relationship holds for every system. There's no exception to it. The number of faces plus the number of vertices minus edges equal 2. Lifestyle with awareness of the otherness, 2.
Cool. Are you complete?
Yes.
Really cool. I'm sure that formula goes over around page 120, and it was talking about triangles and spheres. And I'm sure it uses the n squared minus n over 2 formula there. 2D.
Yeah, that is the number. That is the number of relationship of distinct relationship between elements, between any two elements of a set.
Richard pointed that out, and I'm saying that there was an additional use of the formula because it would predict the number of spheres or triangles. I can't remember which on the bottom row as you added the layers. So I'm going to have to, that'll drive me crazy. I'm going to have to look that up. I've got it in my notes someplace. I've checked on the thing and have been able to get it. Okay, we're ready to go. Welcome to our call. We're 49 minutes beyond the appointed time to start the call, but we've been having a lot of fun. But let's get started with our call. Richard, how are you feeling, and what do you anticipate as we begin to read a fuller explanation on page 199 or 171 is where we are at figure 10.7. How are you feeling, and what do you anticipate?
Well, I'm feeling very positive, and part of it has to do with I guess what I would call serendipity today. I was talking to the current dean of the faculty that I used to work with, who happens to be a former student as well. But I'm preparing to give a presentation to an indigenous social work conference in a week and a half. And It's based on a chapter that was recently published, but I've only got 15 minutes, so I'm trying to figure out how to squeeze it all down and make some sense. Um, and so I was talking with the dean. Somehow or another, we got onto the discussion of our daughter, who's just written her first novel. Um, and so I was telling the dean, and as I was telling her, she was looking up the title and the author's name and saw it. And unknown to me at the moment, she, as we continued to talk, she ordered the book. uh, and and our daughter is going to be here next week doing a reading at a local bookstore. Um, so anyway, I get off the contact with the dean, and I go back to the computer, and all of a sudden there's a message that comes from a former student that I worked with in the late 80s, and one who had written a really good paper along with three other students. And I got those papers into a position where the students were able to present to a conference of social workers. And so that was very um, satisfying for the students to think that their paper was good enough to be presented to a public audience. Um, and then I lost track of that student from the time that she graduated until a year ago. I went to a memorial service for a former staff at the university, and this student was there, and I didn't recognize her right away, and she didn't recognize me either. And then we connected, and so I told her that I'd actually used her paper as a foundation for a news article that I wrote for our suicide prevention group. So she was quite taken by the fact that I still knew what she had written 20 years ago and had actually used it. So this afternoon, and then we had a catch-up coffee, a year ago, let's say, and I haven't talked with her since. And no sooner did I get off the email or the call with the dean, I get a note from this student who said, "I've just read your daughter's book. I have no idea where she got it from, or," and she was very had high praise for the article or the book and the content and everything. and and so I sent it off to my daughter saying, "You've got a fan here."
Cool.
So it was another one of these serendipity experiences that you get every once in a while in your life, where you're doing something, and then the next thing, somebody who has got a connection to that shows up in your life, either on an email or you meet them on the street, or so anyway, that's got me feeling really positive. And so Anne, how are you feeling, and what's your expectations for this evening?
Yeah, first I want to say thank you this morning because just that short discussion on the triangling versus squaring that we've talked about many times, but I think today it got anchored, very nicely anchored for me. Yeah. So I really appreciate us taking the time, to work that out, even though we've done it many times, but just somehow today, just going back towards it. And I've also taken note of this, a full explanation because it showed up in this chapter. I should go back to, hold on, let me get it. It's on page 177. Yeah. And there's just that part where he said it many times, but today it just got anchored. The third last paragraph, where it says Bucky would complete his arc. Can you find it? 177?
Yeah,
You know,
at least in my book, Bucky would complete. Is that it?
yes.
Okay,
Bucky
let
would
me just
complete.
let
Yeah.
me open it up, and and you can read it, and we'll go from there. And so 177, I have to add 28, so that'd be 190, 2. It's only a few pages ahead. It'd be 2, 220. Let's just put 220. And then we'll go down here and see what page number it is. Pardon me for thing. The PDF file page numbers is not the same as the actual page numbers in the book.
Maybe I will help. It says it's in the chapter
What page is on? 177?
Volume reconsidered.
It's
Volume
page
reconsidered.
177, right?
Yes.
Okay, I'm sorry. I'm going to be pedantic here and get us going.
It's after figure 1011.
Oh,
Okay, there's 10.8.
After 1011 is cosmic hierarchy.
There's
And then
10.9.
it's under the next section is volume reconsidered. Next topic,
Okay.
rather. Yeah. Not chapter.
yeah.
Volume
got it.
reconsidered. There we
After
are.
this, the next page. Yes, the next page. Perfect.
Do you want to read?
Okay, yes. Further down, the third last paragraph. Yes, it says, Bucky would complete his argument by reminding us that the cube is inefficient, having demonstrated the respective volumes of this traditional shape compared to nature's minimum system. He would summarize by saying, if you use cubes, you use 3 times as much space as necessary. And once again, nature is always most economical. And it went on a little bit more, but so I'm taking note of that because we did the diagram early on in the book, and then this is like when he talked about this, there's no visual to it until just now when we went backwards to it, and yeah, it just makes sense now somehow. Yeah. And so that's the one thing I want to say this morning. And the other is, I'm so stoked. We're so over the moon at the moment because we think we've created the first, which we can do on computer, a 4-dimensional assessment system. For work, for students' work, and we can literally use it for everything that they have done. Let me give you. Is it okay if I take a bit of time to talk about this?
Go for it.
Yeah, okay, thank you. So about 5 years back, in 2020, we started doing our biosphere curriculum, right? And then we knew that our students were coming out with multipliers in terms of their skills. It wasn't like they learn about the environment, but they are actually embodying the DNA of the environment and also entrepreneurship. And entrepreneurship is slightly different from business, doing a business or a business person, because there are additional elements to it. Like an entrepreneur starts off looking at people and purpose. A business person can start off with, okay, what do they want to use the vehicle they want to use to make money, and it starts from there. And you can have a business, but entrepreneurs is always about working on solving a problem or something, and the people side. And then it goes down the path. And if you can find articles on this, entrepreneurs versus a business person, right? So we actually have our own culture written out for our ACE culture, being an entrepreneurial company, right? Being as an organization, we behave in that manner. So when people come in and think of us as a business and work from that space, it gets stuck. It gets stuck, and then you have that misalignment. So when we went down the path of creating the curriculum for the biosphere, we knew that our students were getting like 5 times multiplier. I give you an example. You're dealing with the one multiplier is academics, right? And everybody has that, the basic of education. And because everybody has that, then is a 1 multiplier, right? Doesn't matter which country you come from, you can get into the same universities. Which education system you come from, you can apply and get into the same universities, depending on results, etc., and interest. Then the second one we realize, of course, is the human interpersonal, intrapersonal skills, and that will be the second multiplier. And if you have that versus a person who's purely academic, then you have a 2 times multiplier, because you're talking about, this is not soft skills. People make the mistake of calling them soft skills. They're actually power skills. And if you don't have academics and you have the people skills, you can still make it really, really big. That's why people can't explain why sometimes a C, D, E, F student does even better in like financially and business-wise and in life, in life, economically, than say a student with A and A stars, right? And Robert Kiyosaki in his book actually talks about that, about C students, why A students work for C students. He has a book on that, right? I absolutely love that because it explains. However, so that would be the 2 times multiplier. When we added the entrepreneurship in, we were like, okay, we had to figure out a way to explain to parents what in the world it is we're trying to do with their children, right? So we realized that when we do entrepreneurship, which comes with business, is a 3 times multiplier. It's not even 130%, it's like 300%. And we saw the outcome with our kids, but we didn't know how to measure it. We didn't know how to produce a report for that. Then we came to 2020, we decided to add in the environment, right? And the environment, we were doing it as a convergence of the 3 E's, which is environment, education, and entrepreneurship. And nobody has actually brought it together and made it compulsory in an education system, so the kids, when they leave, they have this DNA, and they go out there automatically. They would think anything they're doing, they're solving the problem from multiple angles. And we under entrepreneurship, we have these 12 pillars of our entrepreneurial roadmap. Number 1 is create massive value. Number 2 is think win-win-win. And you have 4th and 5th win, even better. We have trust is the new currency, design the money blueprint. And then we also train them on, I can't remember the title now. They have to learn how to do business legally, morally, ethically. And at the end of our the 12th pillar is actually nurturing entrepreneurial leaders who will drive change. That was our ultimate purpose. We started this business part as an entrepreneur school in 2015, but I started doing financial education, teaching it with my students 25 years ago, right? But then when we went down the path of the environment, which we started in 2020, we realized we were giving our students a fourth multiplier, which was green skills. But when you do green skills and all these 3 other skills, then you are also learning and developing impact skills. And we saw it in our kids, how they're showing up. So the minute we went down that path, we said, look, we have to figure out a way to assess this. If we don't, the value of what we're doing, it won't show up. We worked on it for 3 years, and we sat on it for 2 years because we didn't know how to make it work. To create the assessment, right? So then we looked into everything from the 7 intelligences, and we realized that was not complete. And even Gartner himself says it's not complete. They were basing the 7 intelligences out of data they could get. But then there are all these other 8 intelligences. Thank you, Manu. And there are many other intelligences that there's no data for, right? So you're saying like we should be the one to create that and get data, because we will measure that, right? We got the other areas, other intelligences we felt was missing, but of course there's no data to work from. But okay, so where we went with that was we knew it was going to be 4-dimensional. We knew it was because we can actually name it out. We're going down here and this, right? X, Y, Z axis, and the thing is this, all the space in between, and the connectivity in between never showed up. So we just, over the past 2 days ago, we generated it. For the first time, we generated the report. We're loving it because the kid was described based on his portfolio that he created and everything else that you can find about him. The report generated was just so on point with him, right? Except for the musical part, which we haven't added in because he just recently has been rapping. He started teaching rapping classes. And so now not only is he science and math and creative, and he's doing fashion and everything, and the ocean is his thing. He also did rapping, which we haven't added yet, right? But that aside, so we're really, really stoked by this. And now we're going to be looking at who to work with in order to, so where I'm coming from was this. I was teaching in the Canadian pre-university program in KL, Kuala Lumpur, okay? And that's how I got to know the Canadian system way better than most Asians would. And I loved the independent study unit. I loved the fact that there are no exams, like, you know, no standardized exams, right? From primary one all the way through to university. None. It's like you have university, but from grade one. Right now, systems all over the world is you have exams, and all the exams, the way they examine the skills that we teach the kids, don't set them up for the universities, right? So when I was teaching in the Canadian pre-U, I said, oh my God, this is the university education brought down all the way to high school, which was the senior high, and then all the way down in like as in your system in Canada, right? But I also knew that I was struggling with when I started doing my school based on the Canadian system. Actually, yeah, I created it out of okay. You know how the eight intelligences by Gardner, it has a lot of focus in a lot of people. It's big in the Western world, but in Asia, nobody cares. Nobody cares a hoot as to all the other intelligences and how it should show up. Yeah. And so when we went down the path, when I saw the Canadian system, I was blown away by it. So imagine I've been familiar with the Canadian system since 1991. Okay, so I created our curriculum out of that experience in 6 years in Canadian pre-U, right? But then what we did was we merged it with the Asian, what Asians expect. And that's why I can never do a Canadian school in Malaysia or any other place. I have to use Cambridge. Does that make sense? Because that's what parents want, right? But how we deal with it in the classes is completely Canadian. So, but anyway, so best of East and best of the West now. So what happened during then was every time we did assessment, I realized this is in America, US, America, Canada, Australia, New Zealand, many of the Scandinavian countries. If we do activities and coursework that is not exam-based, when it's not quantitative, it's more qualitative, there is no system to assess. We have to create our own rubrics, etc. And I knew it was never ever complete. And if you do a report, you do one that's written up and it's very short. But then you cannot accumulate all the work they have done and generate one report. And worse still is because the kids, the skills that they acquire, it starts from primary. If you're doing it, you know, you're doing coursework and everything, primary and secondary, at primary one all the way, you have so much work, right, accumulated. But there's no one person who can create a report, an assessment of all that they have done. Does that make sense? So that has always been bothering me. And so when we started down this path 5 years ago, we said we got to solve this problem. We got to solve, how do we then we also took into context, you know, we can look at the 7 intelligences and, you know, the framework that we created for 5, 6, 7 times of multiplier. But how do you do that when the child is a child? When the kid has gone to become a preteen, a teenager, you know, old like and then the second half of being a teenager, how do you pull that into consideration when you judge the child, right? You assess the child. So creativity, a child at 1 year, at 7 years old, is different from creativity at 12, 15, and 20. Yeah. So we were like, okay, we sat down and we figured out and put it into a rubrics as a whole table. We did a table using Excel sheet, you know. So it was extensive. And then, okay, from here, what do we do with this information? So finally, 5 years later, we have pulled out a report that we absolutely love. And I just showed it to the boy's mom yesterday. They're in Hong Kong right now. The boy is 15 years old, and he was interning. He just finished his internship with the broadband company in Hong Kong. It's the largest and the only one. And he was working with the CEO and COO. He did a presentation. They are going to be implementing his solution to a problem they have. And they're going to write him a report, because the report that we generated, the summary is that he is beyond high school. He is doing work at university level, but the COO and the CEO just said he's work ready at C-suite level.
Wow.
Yes. So they're going to be writing a report on that one. And that's the outcome. That boy's been with us since he was 9 years old. He gave up his world schooling because he found a home to world school from. And so the mom is like stoked because he's getting a lot of all the other things. He's got a childhood, he's got a teenage life, and he's got all the things that is needed to build all his skills. And he's in X Prize, he's with the ocean, manta ray conservation, you name it. So he could do all of that, and everything is assessed. The mom is so stoked, so are we. So I'm just letting you know that we're gonna see what we can do with this and how to take it further. Okay. Okay. Now I'm done. Sorry. Okay.
You want to pass it on to somebody else, Anne?
Yes. Okay. Manu, how do you feel, and what would you like to take away today?
I feel excited. Thank you, Anne,
Manu,
for sharing.
and Manu, just like everybody else, keep it down to 2 hours, okay? No, go
I'm not
ahead.
guilty. I'm not
Take as
I'm
much
not
time as you like.
guilty.
I'm only
I'm
kidding.
not guilty today, right? Not yet guilty, right?
Good.
So I feel good, you know, and then I think that this train is really dividing to multiply. And that's what I expect more. So in practical ways, to divide to multiply. And I put, just complimented Anne here, what I perceive are the 8 intelligences in the chat box. One of them being the proprioceptive. That is a spatial orientation, that ability to be able to find yourself. Some people are quicker to know where they are. I first say environmental, but Susan will call it proprioceptive.
Ah, right.
And the other is entrepreneurial. That is problem solver. People think that mathematics is problem solver. That's the difference between engineering and mathematics. Engineers are trained to problem solve. They train that intelligence. But yet they use it poorly in terms of, you need at time, you know, when we say to look from a whole, is that actually you should put together in a system those strengths, those intelligences, to be able to have a team grapple with complex problems and solve them in the most comprehensive way possible. I'm true. Anne, Lee, how do you feel? What do you expect?
This has been fascinating. The talks before we even started. I think I've got a sound reverb. How do I get rid of that?
I don't think you can get it back. I'll turn off my thing. Let's see.
Much better. Much better. Thank you. Anyway, I've been fascinated because I'm looking back at my life and where it started and how I developed into the person that I have become using what Anne has said. but making it more difficult. I wished I had met you long time ago, Anne, so
Not too
that
late.
I could write my history, I think, a lot easier using what you have taught me just a few minutes ago. That's really good. I've been wanting to do that and putting it into perspective. Everything, the triangles, as we talked about earlier, and then the squares, all equaling in the same amount, but the space taken more space with the squares. And it's wonderful that the triangles are a whole lot less because it's natural, it's nature. And I like that. I have always gone for the natural and easiest way. Being a diabetic, I have lived 70 years with diabetes, and I've gone natural more than my doctors wanted me to. And I said, no, I'm not taking that medicine. It'll do me in. You'll kill me in 2 seconds. and which is very, very personal, but also helpful for other people. So maybe in my dissertation that I will write about myself, with Anne's help, maybe I can help others with the same situation, especially after being 70 years of diabetes. But I've conquered over a lot of my illness by using nature. Nature is wonderful. I like those triangles. Steve, what do you think of how do you feel and what do you have to say?
Well, I'm bubbling all over. Number one, I want to go to Anne's school.
Yes.
It's so funny because when I was in college in 1967, 60, about the last year I went to university for 6 years. I never graduated. Oh, okay, cool. You may want to put yours on mute. I went to university for 6 years. I never graduated. I had 5 minors and no major. I could have gotten a general studies degree, but nobody in the German linguistics, philosophy, communications, political science, and music department knew about a general studies degree. So I didn't ever get a degree. But it was amazing because that class I took a class on transformational grammar and syntax. And it was amazing how I just prospered in there. I wrote more songs than I started writing more songs in my rock and roll band. I got an A+ in that class, and the other people were struggling because they just wanted something to memorize. And solving problems is a whole different skill set than memorizing. So anyway, I just related to your whole conversation about entrepreneurial. My stepdad said that I would either be a bum or I'd be rich, and I've been both. And that's because of my ADD. I do whatever it is. I solve problems, and if the problem doesn't pay me money, it doesn't bother me. I'm solving it anyway. And when it does pay me money, that's a wonderful thing. I wanted to do a couple things on Manu on this proprioception. This proprioceptive intelligence is important because that's where sports are. Like some people can kick a ball and make it spin around. Some people can play pool, and they know how to put the right English on a ball. This is proprioceptive intelligence. It's how I place myself in the universe, and it's how I kick a ball. Some people are really good at kicking a ball. Other people aren't. And so proprioceptive intelligence, I wanted to reinforce what Manu said there. Richard, I want to reinforce what you said. I can't even, I mean, I got close. I got a little story I could tell, but the idea that I would go speak to the dean of the college, who was once my student, that blew my mind. That blew my mind, Richard. Right then I thought, holy crap, what have I been doing with my life? Because yeah, and I've had some pretty close experiences, but that was cool. And so I'm just really honored that you're taking your time to be on the call. And let's see here, this whole idea of triangles. When I was in marketing at BYU, I was in the marketing. That was one of my minors for a minute. But they talked about solving perpendicular solutions and lateral solutions. Like they gave case studies of one case study that was classic was all these people were stuck in an elevator in New York, big traffic, big buildings. One building is a zip code in New York, and big, and people were quitting the job because they had to wait for the elevator. So they brought in these consultants and they figured out that it would cost them so much money to rebuild the elevators. They'd have to destroy their work hours and everything. And somebody came up with the idea of just putting mirrors in the elevator so people could look at each other, and it solved the problem. Lateral solutions to problems instead of perpendicular solutions. And this brings us to triangles and squares. And I'm really convinced that thoughts are triangular and tetrahedral. They're not squares and cubes. And I was just talking about this with somebody today. I say, our language expresses that amnesia. We create amnesia by using words that don't mean anything. And I went through this whole thing: sunrise, sunset, sunset, sun clips, right? And the more I say sunset, sun clips, the more natural it sounds to me. And the brain fog kind of goes away. And it was kind of, oh, okay, I kind of get that. And I wanted to go ahead, if I may, and just share, because I found that formula thing. It was in the book here on page 170, 120 of the book. And you look at figure 8.8, and this is exactly, whoops, I just clicked too far. Pull her up. Okay, here we go. I want to start at this paragraph and just go through this, because this will help you, and it certainly will help me. We start very simply with the phenomenon of triangular numbers, a sequence of numbers that in which each successive term is equal to the previous term plus the number of terms so far. It kind of sounds like a Fibonacci sequence, doesn't it? These numbers can be generated by triangular collections of balls arranged as in a rack of billiard balls. The total number of balls in each triangle in the series of progressively larger groups is a triangle number shown in figure 8.8. And it shows the first 5 groups. The first member of the sequence is 1. The second is obtained by adding 2 to the first to get 3, and the third by adding 3 to the 2 to get 6 to the other 2 sets, and so on. Each successive number is generated by the addition of a row with one more ball than the last. The sequence of numbers thus generated, 1, 3, 6, 10, 15, 21, 28, is specified by n squared minus n over 2. For n equals 2, 3, 4, n equals 1 corresponds to 0, which is not, strictly speaking, modeled by a triangle. But here's where the formula predicts the number of balls that are going to be on that next row. And it's the same formula of the relationship formula. It just looks at a different aspect. The relationship formula is at least 4-dimensional, because every time you add a vertices, and all the vertices are connected. So it becomes a hypergon. This is 2-dimensional. But this, in a 2-dimensional space, this formula, n squared minus n over 2, predicts the number of balls, calculates the number of balls that'll be on that next row. So that's on page 124.
Yeah, oh, forget.
Okay. I knew it was there somewhere.
Yeah.
And it says the formula n squared minus n over 2 might appear to be a more difficult way to obtain these values. And certainly for small groups, it's easier to count the balls. But of course, for the 20th or even the 9th triangular number, it's far more direct to subtract 10 from 10 squared and divide that number by 2 to get 45 than to draw out the rows and rows. Mathematics presents a shortcut, otherwise known as generalized principle, Anyway, I thought I would share that because I thought that was My memory served me, and all I had to do was go look it up. I'm looking at. Okay, good. Let me see if there's anything else on my introduction here.
Has everybody been? Has everybody introduced?
Yeah, I'm not quite done yet, but I think I'm the last person so far. And I'd like
Can I
to
say
finish.
something on what you said?
Okay.
And I think you should make the experiment that I made with us. I always say that, you know, when we got into what we call secondary school in those days, because there was GCE O level first and then advanced level. So there was, when you get into, after 6 years of basic education, in grade 7, you got into, you know, secondary school, from elementary to secondary. And for 3 years or 4 years, 3 years, they ran an experiment on us where they taught us mathematics without ever calculating anything. And one of the things that were used were Venn diagrams extensively. And this is Steve's stuff here. Steve, capture this.
Okay, hang on 1 second. I have to pin you out. Okay, you're now pinned and I've got you.
Okay, can you show?
I will. Okay, and here comes the share. Okay, there's the picture. Give me a minute and I'll make it smaller first, but then I'll make it bigger. Okay. Is that
Okay.
good?
Yes. You see,
Whoops. Too big. Okay.
no, it's okay. Those two bulbs that are there, like your whatever. So you see the first, let's just say that any number of people that find themselves somewhere or that exists in a certain set, say n can be anything. So if I put those people and I had a mirror, those people will appear in red, right? The same. Now, two principles. If I'm in a relationship with Anne, it means Anne is in relationship with me. That's called a reflexivity. The second thing is that I cannot be in relationship with myself, or I'm always in relationship with myself. So that wouldn't count. So if you see number 1 there, I took number 1. You see, I put it in dash, the relationship to number 1. If I want to count the number of independent relationship, you see that number 1 is in relationship with n minus 1, different from himself, right?
Right.
Now, how many ones do we have? We have n. So those independent relationships are n multiplied by n minus 1. Are we there? Each person minus himself
Yeah.
has
That's
n.
like saying it's 4 times 3 or 5 times 4 or 6 times
Exactly.
5.
Yeah. But because when I'm in relationship with Anne is also in relationship with me, it means I've counted twice.
Yeah. So you don't divide by 2.
Don't divide by
I
2.
divide by 2.
No, you
We're
don't.
talking about relationship. I say so. I say, if I take the 1 in the first block, that one relates to n minus 1 in the second block.
Mhm.
And there are n of 1 in the same block. You know, there are n ones. So the number of relationships is n times n minus 1. But when I say a relationship, it's always 2 relationships. Because if I'm in a relationship with Anne, it means automatically that Anne in relationship with me. That's why you have a mirror, which is the real one you don't know. Right? So when you count that in that multiplication, you have to divide by 2 in order to iron out the double counting. That stems from the principle that when you talk about a relationship is always between 2 individuals.
Yeah, what you're
That's the
talking
way-
about is you divide by 2 in order to get the single connection. If you don't divide by
Yes,
2, then you get the reciprocal.
Yes. So that's the way they taught us this.
Mm.
In a very, we used to draw actual fact. I mean, I studied mathematics for 3 years without ever doing 2 times 2 is equal 4. I never did that.
Mhm.
It was always relationship, sets,
Mm.
elements, how they relate, how they complement each other. What is the intersection of? What is the neutral element of this thing? What is the absorbent element of this set? Right? We know that in the decimal system, the absorbent element is 0, but they never told us 0. They just say absorbent element. It put it in a generalization of sets, not one that you were boxed in a numerical counting. And I think in terms of teaching, and I don't know, if you go and do research, I was just, subject of an experiment, but it had a long-lasting impact on us. I take it because my younger brother is a PhD in physics, but we don't reason the same. He did not go, he went to a different school from mine, and that's the experiment where he didn't go through it. And we are different. We are really, I mean, up till today, we are very different. So it molded, what do you call it? It primed my mind into a certain direction, and his experience primed his in another direction. There's an angle between two.
Manu, actually, I've been very interested since the last time you shared with us that you went through a very different math, education system, right, for the math side. So yes, I've been interested in it since the last time we spoke about it. Yeah.
Yeah. Do research. I don't know where it is. I was a kid. And I've never done research on it. But look, research what they call in the 60s modern mathematics. Canadians, Richard, should be able to find that. Because he was run by Canadian and French. They were very strong into it.
I want to bring up to what I haven't finished my introduction yet, and I just want to
Sorry,
add.
Steve. Sorry for
That's
stealing
okay.
your time.
No, it's okay. We're here to share. I want to share this because this is exactly the divide by 2 issue. N squared minus n divided by 2.
Exact. Yes.
There's your AABBCCDD. And the reason why we divide by 2 is to eliminate that. Because there is an interrelationship here. A relates to A, and B and A relates back to A. But that's the divide by 2. This is a chart showing that formula. Anyway, thought I'd say that. And what happens is we take this whole chart and leave off half of this chart. In another chart, I have it grayed out. I have half of that chart grayed out because one is the sine and one is the cosine. One is the visible and one is the not visible.
Exact. And
So
it's not because you don't see that it doesn't exist.
Right. So anyway, here's another chart that I share, and I've shared this before, but
And Steve,
yeah.
And Steve, Just one interjection there. The visible, what we call the visible, is actually a derivative. It's not the original. It's not the pure. It is a projection onto something that we see the image. It's a cosine. That's why they call it cosine.
Yeah.
Sine
Manu,
is, yeah.
no, that's cool. And I think it's important. And I showed beforehand how Jordan Peterson argues that facts are not a way to relate to the universe, that there are as many facts as there are things, and that this is being proved, he says, in neuroscience. And this is the whole idea that I don't see reality anyway. All I see is photons hitting my nerves, and my brain interprets it a certain way based on my environment.
Yes.
And so I'm not seeing reality anyway.
Yeah. And can
I'm
you
seeing a
imagine that you
projection.
can teach this way to, when I'm talking about that experiment, I was 12
Yeah.
to 12 years old.
Yeah. Anyway, here's the divide by 2. This is right away I divide by 2, because then I end up with this over here, not with this over here. Anyway, there's your sine and cosine, visible and non-visible.
And
Cool.
see again, when you divide by 2 there, the two are not side by side. They embrace.
Yeah.
One face come. Can you see that?
Yeah.
If we take one, it is at 90 degrees of the other.
Right.
Do you see it?
Yeah.
You know, the lower part is at 90 degrees of the upper part.
Mhm.
What does it call? What is it called? What does Bucky call it?
90 degrees is orthogonal.
Yes, but what does he call it in the degrees of freedom?
What does he call it?
He call it perception. Oh, how do you call it? When you drop a rock in on a water body and you have wave going at 90 degrees.
Precession.
Precession. That is precession.
Cool.
The two embrace at 90 degrees to make a whole.
Which is what electromagnetic waves do
Exact.
at 90 degrees.
Yes.
Cool.
And which is what gravity and electromagnetic do.
Yeah.
Because those are, you know, and this is what electromagnetic and nuclear do. The 4 forces that we identified so far: electromagnetic, nuclear, gravity. They all act as the 3 grand circles that are cutting the octahedron in a tetrahedral universe that is 4-dimensional.
And so,
Did we?
go ahead.
Yes.
Go ahead.
I'm just saying, if you take that, what we just discussed that now, and put it in the grander theories of today, you will see that you have 3 grand circles: electromagnetic, gravitational, nuclear, describing the 4-dimensional sphere of universe. Because when you take those together put, you have the octahedron and the greater tetrahedron around it. We had it in page, if you take page 174, 174 on B, 174B of a book, you see the 3 squares or 3 grand circles, as Bucky called it, great circles that are cutting the tetrahedron into a system that fully describes it in 4 tetrahedra and 1 octahedron. I'm true.
Okay, good. So this again relates to this concept of topological versus topographical. You know, I see things topographically. My brain likes topography, but the reality is topological. This is the reason why a donut and a coffee cup have the same essential structure.
Topologicalness.
They just manifest differently on a topography. Topology is non-dimensional and topography is dimensional. Anyway, I'm still trying to understand those things, so I thought I'd say those words. So I'm looking forward to a discussion here tonight, even though we only have like 15 minutes left, and it's really time for takeaways. I wonder if there's anything let me look at the book real fast here and see if there's anything that we could do in just a couple minutes.
What page were we in the book? What page were we?
We're on page 171. We're about to tackle vector equilibrium.
But we've already discussed all of that now.
Yeah, we have really. And you know what comes up for me is that chapter, Richard sent to me a video from Jane 108 about the cube and the tetrahedron and how you do. Let me see if I can find that really fast. Let me see here. I can find it for sure in my emails because
I think he showed it in a page 174. Shows it everything that we've
it is
discussed.
on 174, but what's missing in that book is the animation, and what Richard sent me was a perfect animation of showing that cube thing.
Of 10.7.
Yeah, of 10.7. Let me think if I can find that here. This is, I'm gonna go Jane 108. Jane. I wish I'm gonna get a better computer one of these days, or I'm gonna get two so I can have one that does all my research on it and the all my searches and stuff, and the other one just does my Zoom calls. Then I'll just switch over to screens, and so let's see if I can find it real fast because that was a cool. Jane actually showed tetrahedron to cube thinking. I think he called it cube thinking, I think. Well, I'm not going to be able to find it. Maybe I'll find it during the takeaways and I'll share it there right at the end. I think I can find it on my phone faster than I can find it on thing. Okay, good. So let's go ahead and start our takeaways. Richard, how are you feeling and what are your takeaways tonight?
Well, I suppose it's pretty much the same as I started out, feeling very, very positive um, and I guess my big takeaway is the kind of thing that Anne was referring to earlier, that sometimes the obvious that we read doesn't come across that obvious right away. And then there's something that later on is either said or read or explained that all of a sudden it makes sense. I get it. I figure it out. And that's always the kind of takeaway that I look forward to, is that out of the dialogue between however many of us are engaged in it, very often the dialogue creates an understanding that I didn't have on my own. And it really speaks again to two heads are better than one, or all of the other kinds of things that come out of working together in a co-creative, if you want, way. Which, and I'd really like to get another visual of the four-dimensional assessment that you've developed, Anne, just to sort of experience it visually, um, and feel the excitement that you have in developing it, and more importantly, the excitement that is in the young student and his parents in seeing how this all kind of fits together. So my takeaway is along that line, but my takeaway is also I'd like to be taken into a visual of that four-dimensionality in a way that I fully sort of grasp it. Yes. Um, so I'll just continue that way and over to Anne. How are you feeling? What's your takeaway?
Yeah, thank you very much. Okay, let me fine tune and sort out exactly how we're going to put into words what we're doing, and then I will share it later on when once we get that. And then I also need to find somebody to work with, people on the IT side who may be able to help us pull this together. But thank you for the feedback. And the thing is, actually, I need to thank Richard, Steve, Manu, and Lee for joining us. But Richard, Steve, Manu, because all the discussions we've had, I think it's like the coming up with stuff. It's about growing the mind, right? And growing the mind, a lot of people don't really understand what that means either, right? And over the years, because of the training we've had with American trainers, is that the left brain and right brain, what every time we do new things, every time like we talk like this, it's new information, new wiring, yeah. We get a lot more wiring connecting between the left brain and right brain. So over the years, in this group, but as we discussed, we never went down one path and it sticks it just like one in like one I would say like one discipline or something, but it kind of relates to everything. We look at the whole world, we look at the universe, we look at out in space and down to the ground and into the world of the invisible, etc. Right? So with that, I realized that it's been doing a lot of connections, and it's allowed me to look at all things in new ways, or figuring out even better ways of solving the things that we are struggling with in education, right? So I just want to say thank you so much to every one of you here. Okay. Yeah. For that, you're seeing what I take away anyway. Yeah. In the things I do, those are the things I've taken away today. The math thing. Every now and then I toss something at my math people. So this time around, I think I'm going to toss a bunch of buckets at them, not just one thing at a time, and see what comes out of that during my next meeting. Okay, so over to Lee. How do you feel, Lee? And what did you take away today?
I feel wonderful. Hopefully my volume is up. There we go. Steve, you'll have to turn yours off.
Okay.
Anyway, I have learned an awful lot in our discussion tonight about understanding people to help you out, such as Anne. Manu has helped me many times because I don't understand math. I have never understood math, and so he has helped me. Richard has given me wonderful stories, and so it's a group of pencils in a purse, as Manu has said, that we are a group that can gain information from each other and come up with a different perspective, which is wonderful, such as Anne finding out her way of getting the history done on a student and finding out what he developed in his short life and what can happen in the future. That is so fabulous. And I am feeling very good about that. Manu, what is your feeling tonight? And what is your takeaway?
Lee, it's always wonderful to listen to you. Really, it is. Kudos. I'm excited, and I have, this discussion this morning was really brought many things. The 8 intelligences, if you look at them, they can divide it into 2. The first category, that is verbal, mathematical, musical, kinesthetic, is all visible. It all manifested visible. It is visible. And the other 4, interpersonal, intrapersonal, entrepreneurial, proprioceptive, are not visible.
Mm.
So you have again there the duality of 2 tetrahedra coming together to make a whole. The second thing is the entrepreneur. And I think that the entrepreneurs, his role, first, I want to note that energy is power in motion. That's the definition. If you look at the formula of energy, that's the way it's written, or power, depending which one is egg and chicken. Energy is power in motion. Now, the entrepreneur, there are many potentials into this world, many points of accumulation of energy. Those are vertexes. The entrepreneur, from French, entre, that is in between, and preneur, that is you move, you take. So you have to build bridges between those vertexes to allow the flow of energy. And if in so doing, you ignore some of the vertexes or some of the bridges that must be built, you're not going to have a fully flow. And that's why Anne's trying to integrate it into a measure that can be taught and that can be appropriated by others is very welcome, because you are going from a whole to the elements and backward. And then another takeaway is from page 174. And it arose from Jordan Peterson interview about what is going on today. If you realize that everything that we've been talking about, all the cognition to date, has been kind of categorized into 3. The electromagnetic, beautifully described by Maxwell's equations, wave and the particle. The gravity, from relative, like a special case of relativity point of view, that's Einstein. And the nuclear, that is quantum mechanics. And then you realize that when you take at page 174 of this book, the figure 10-9b, that has the octahedron in the great tetrahedron divided, you realize that those forces, those categories that we talk about, they correspond to the great circles that Bucky talked about. The 3 great circles that come now second degree derivatives, divide now the octahedron into determining the 12 parts of a total. Unity is plural at the minimum of 6, with duality at the minimum of 12. That's why we talked about the 12 degrees of freedom. We want to describe a whole system in terms of our divisions. We have to talk about the 6 degrees of freedom that are in the cosine domain in what we see. That is the spinning, the orbiting, the torque, the precession, the inside out or packing, and the expansion contraction. Those are the 6. But those 6 physical have 6 corresponding metaphysical, right? To make 12. It is a concave and a convex. So seen from that point of view, you start making what we call a whole sense. That is, you start acquiring some wisdom. And that's what I take away from our discussion today. Linking those things. Otherwise, I'm grateful and I'm thankful and I love you all. Steve, how do you feel? What do you take away?
Well, I'm frustrated that I can't find things when I look for them. That really drives me crazy. I'm going to look for that half an octahedron plus a tetrahedron makes a cube video, Richard. If you find that thing around anywhere, it was your video. I think you sent it to me, and I thought it was really cool. Somehow I didn't catalog it properly. And I've been busy working on the project, and I just haven't taken the time to catalog stuff, and that really drives me crazy. Look, I'm so grateful for each of you and your perspectives being on this call. There's much to live up to in my life. So thank you all for being exactly who you are and making the contributions that you're making to the universe. And in 2 minutes, we have 2 minutes for anybody who wants a final statement. I'm complete. Otherwise, we'll meet next week. Everybody complete?
Yeah.
Okay. See you all soon.
Bye-bye.
Bye, beautiful people.